Welcome back. In the last lesson, we saw how we can put everything together and how we can build our decision tree, how we can use the fit function and how we can use the predict function, right? We build it using object-oriented programming. Now, we want to know how we can evaluate our implementation because in the next lessons, we want to compare our implementation with the sklearn implementation. So that's why we have a function here called decision tree evaluation, and this function takes the object itself, right, the decision tree itself, called ID3, and it takes x, y, and verbose, right? And verbose is actually used if we want to print the accuracy, right? So this is an optional input or an optional parameter for this function. It's false by default, so we don't really print the accuracy by default, but if we want to print the accuracy, then we will set this variable to be true, right? So let's see how we can evaluate our decision tree. So as you can see here, first we are creating a variable called yPredicted, and this is an empty list, and x is basically the full test dataset, right? So this is the full test dataset without y. We have y corresponds to the true labels. So what we are going to do is that we are going to iterate over all the records in x, right? So we are going to go over all the rows in the test dataset, and we are going to use the predict function inside ID3, inside the decision tree we have built, right? So we are going to write ID3.predict record, okay? So this will return the predicted label, right? So what we are going to do is that for the first iteration, we are going to have 1, for example. The second iteration, we are going to have 0, and so on, right? So we are going to have at the end a complete list, and this list will contain y predicted overall, right? So the first index will correspond to the prediction for the first input, right? For the first record, and so on and so forth. So how we can compare the predicted and the true labels? We can do this in multiple ways. You can do it any way you want, but one of the most efficient ways to do so is this way, right? So this is called list comprehension, right? We didn't really discuss it in this course, but it's discussed in the other course, in the Python course, if you want to see it, right? Because in the other course, we dedicate the whole course for Python programming. So we are discussing everything there, right? You can see 16 hours or more than 16 hours of content in the other course. But right now, we want to focus on the machine learning part. So what I am doing here is called list comprehension. And this is very, very similar to just write results equal an empty list, okay? And then we are going to write for prediction and truth in zeb y predicted and y, right? So this will give you, this will zeb y predicted and y. So we have a tuple. So each iteration, we will return the first prediction and the first true value, the second prediction and the second true value, and so on. So what we are going to do is that we are going to write here results dot append what? Prediction equal truth, right? So basically the results will contain either zeros or ones. If we have a value of 0, then this means that this condition is not met, right? Because this is a Boolean condition. So this will return either true or false. It will return either 0 or 1. It will return true or it will return 1 if the prediction is the same as the true value, okay? And it will return 0 or false if one of them is not equal to the other, right? If they are not equal, then this will return false. So the results is basically a list that contains if the predictions are true or not, okay? So these 3 lines are exactly like writing this line, right? So this is a more efficient and more comprehensive way to write your list, right? Or to have a list comprehension. So we can remove this for now, but I just wanted to show you that we can write these 3 lines or this line. If you want a complete lesson on list comprehensions, when they are used and so on, you can go to the Python course and check this part, okay? So we have these results. How we are going to calculate the accuracy? It can be done very, very easily. We can just go to this list, and we have a built-in function in the lists called count, right? So if we have, for example, a list that contains 1, 2, 1, 2, 2, for example, so we have 2 1s and 3 2s, right? So if we write results.count 2, then this will return 3, right? So this will basically count how many occurrences we have for this specific value in this specific list. So if we write results.count true, this will return the number of true predictions, right? So here we have, let's say we have 100 examples in the test dataset, and inside this results list we have either true or false. So let's say we have 80 out of the 100 are true and 20 of them are false. So this will return 80, right? If we divide this by the length of the results, right? So we will divide 80 by 100. So this will return 0.8. So this is how we basically calculate the accuracy. Of course, you can use the sklearn implementation or the sklearn function to calculate the accuracy, but this is basically how you can do it if you want to do it from scratch. Okay, so this is the decision tree evaluation function. Now let's test the decision tree we built, right? Our implementation for the decision tree on the dataset that we used in the very beginning, the adult dataset, right? So here we have the columns names, right? And we are loading the dataset again. And we said that we are going to use this dataset as a training dataset. So that's why I'm calling it right now df_train. And we have the header equal none and names equal columns names, right? So I just copy pasted this part from the very first lesson in this section. And I'm also dropping the column called fnlwg because it contained so many values and it was not really necessary, and it can make your code run very slow, because as we said before, we are going to try each single value for each single feature. So if we have a feature that contains so many unique values, then the decision tree will take a very long time to run. So that's why I'm dropping this column for now, right? So dftrain.drop and then the column we want to drop and in place equal true to drop it in place. So we don't really have to write dftrain equal dftrain.drop and so on, right? Now, if we run this, you will see that we have now dftrain and the dataset is actually great. Now, let's do the same for the test dataset and we are dropping the same column, but as you can see, the first row is incorrect because if you remember, when we opened the adult test file in Excel, we saw that the first row was 1 times 3 cross validator and then we have empty spaces here. So by default, pandas will fill the first row with this value and then all the missing values will be none or not a number. Okay, so how we can drop the first row? We can drop it using .iloc, right, index location, and we will choose all the indices, all the rows from 1 till the end, right? So that's how we can drop the first row. If we run this, you will see that we have the dataset after dropping the first row. And after that, of course, we want to split the data. So we will split it into xtrain, ytrain, and for the df test, we will split it also to xtest and ytest. But if you see the ytrain, right, if you see the target, you can notice that it's actually categorical, right? We have a string here. We have either less than or equal 50k or more than 50k. And this is not acceptable, right? So we need to convert this categorical variable to a numerical variable. So the easiest way to do so is using the label encoder from sklearn. So here we are creating a new object of the label encoder and we are using the fit transform function inside it, right? And the fit transform function will take the data frame or the series, right, the pandas series you want to transform. So what happens in this function is that it will check all the unique values, and we have only 2 unique values for this categorical variable. We have either less than or equal 50k or more than 50k, right? It will map every less than or equal 50k to 0 and every more than 50k to 1. And that's it, right? So as you can see, ytrain after fitting the transform or after encoding the labels is now 0, 0, 0, 0, 1, 0, and so on. So we have zeros and ones. We have now a numerical variable, right? We will do the same for y test, right? And now we will convert the data frames to numpy arrays, so our implementation will work, because as we said, we are going to work with numpy arrays, right? So here we have xtrain to numpy, xtest to numpy, and here we have the xtrain and xtest after converting them to numpy arrays. Now the maximum depth is 3. We can change this, we can have it as 4, as 5, as whatever we want, right? And the initial depth is the depth we start with, right? So this is for initializing the object, right? For initializing the decision tree object. So as you can see, my decision tree, and we give it the maximum depth, and when we fit our decision tree, we give it the initial depth, right? So if you check here, you will see my decision tree should take for the fit function x, y, and depth, and this is the depth of the node of the tree, right? So the first depth should be 0. So here we are building the decision tree using the maximum depth, and then we are fitting the decision tree using x train, y train, and the initial depth, right? Now after that, we will evaluate the decision tree. So let's run this. After that, we are going to evaluate the decision tree using ID3 dt, right? This is the object of the decision tree, right? This is the object for the decision tree here, and then we give it x test and y test, and of course we can give it verbose equal true or verbose equal false. And as you might have noticed, it's taking some time to run, so it will take a few seconds or a few minutes to run, right? Based on how large the dataset and how well you pre-process the dataset and so on. But most importantly, because the decision tree checks each single feature and each single value for each single feature, right? So it takes a lot of time to run, and we will see this when we go to the pros and cons of the decision tree. But for now, let's see the error that was thrown, right? So let's debug the code. So as we can see, fitting the decision tree, this was the message that was printed at the beginning, and as you can see, there is no problem here because the problem is in the decision tree evaluation, right? So when we went to the predict function and when we did the comparison, we had an error called less than or equal is not supported between instances of string and float. So this means that here we had a string and here we had a float. So this means in our dataset, in our test dataset, we have a string that should be an integer or a float. So in order to debug this problem, let's go back to the test dataset, right? So this is the test dataset right now. Now, if we come here and check using info, right, you will see that we have the same variables, but you can see here that for the age, the data type is object. It's not an integer like the training df, right? So if we check df train.info, you will see that we have here integer 64. So the age is an integer, but here the age is an object. So how? You can see here it's an integer, right? No, it's actually a string, but you cannot really see the difference between integers and strings from the data frame as it is right now, right? So how we can change this? How we can convert this string to an integer? We can do this using a function in pandas, right? We can come here and write this function. So we will write df.test, and which column we want to change, the age, right, will be bd dot to numeric, right? So to numeric, convert argument to a numerical type. So it will convert the string to numerical. It convert the object to a numerical, if it's possible, right? So we cannot really change association or some college or private or whatever to integer, right? But if we have some integer or some float that is actually inside a string, we can convert it to a numerical with no problems. So we can come here, df test, and then we write age, right, bd dot to numeric, df test age, right? So if we run this, now if we check the dataset again, you will see now we have age as an integer, right? So let's run everything again and try to fit our decision tree. So if we do so, it will take a few seconds. And here we are, we have an 80% accuracy for our decision tree. So this is actually a pretty good accuracy, right? So we might need to check also other metrics, right? Like the precision or the recall or the F1 score. But right now, that's enough for now. We want to check the accuracy just for now to make sure that our implementation is correct. And in the next lesson, you'll compare it with the sklearn implementation. But before we go to the next lesson, let's look at the final tree. So if we write ID3, right, tree, we said that the maximum depth is 3, right? So as we can see here, the first feature we split our dataset based on is index number 4. And the value for this was married CIV spots, right? So equal, this means we have a categorical variable, right? So this was the variable for the relationship, right? And after that, we have the third index, right? Index number 3. And less than or equal means this is a numerical variable. So this was the split value. So anything less than or equal to 12 was in the left hand tree, and anything more than 12 was in the right hand tree, and so on. You can read the tree as a dictionary from here, right? In a future lesson, we will visualize this tree we built, right? And we will compare it with this dictionary, and you will see that it's actually the same, right? So in the next lesson, we will go to sklearn and see how we can build a decision tree using sklearn and compare our implementation with the sklearn implementation. So let's go to the next lesson.